How does a low-voltage battery like a car battery generate so much current, and a high-voltage device like a taser generate so little? I know that car batteries are only 12 volt, which is quite low voltage, but they advertise being able to generate 400 or 600 amps of current. A taser is a high-voltage device, but delivers a current measured in milliamps. The part that confuses me is that I thought you only had three things: voltage, current, and resistance. And basically the voltage is the potential difference in electrical energy between the two terminals, and the amount of current that actually flows is determined by how much resistance is resisting the transfer of energy between the terminals. What am I missing? The part that confuses me is that I thought you only had three things: voltage, current, and resistance. You do, but remember that the battery is part of the circuit, and it has its own internal resistance. So, for example, if you have a battery that is 12V and has an internal resistance of 1 ohm, it's never going to be able to supply more than 12A of current. If you were to connect said battery to a 1 ohm load, you have 2 ohms of total resistance. The current will be 6A, and half the total EMF will be dropped internally, so the voltage across the battery terminals will only be 6V. A car battery is able to supply very high currents despite its low voltage, because it has a very low internal resistance. If you put 8 AA batteries in series, that also gives you 12V, but you won't be able to draw more than an amp or 2 as the internal resistance is much higher. A taser contains an internal voltage multiplier circuit whose behavior is much more complicated than a simple resistance. But still, the fact remains that it can only supply so much current, and if you try to draw more than that, the output voltage will drop. The taser might put out tens of thousands of volts open circuit, but when it is actually delivering a shock to a person, the voltage will be much lower than that. For a taser, this is by design. They are not meant to be lethal weapons. The circuitry is specifically designed to not be able to deliver too much current. This is a very flawed analogy, but it's ELI 5, and helps understand how current and voltage can be different. Current is the amount of stuff being pushed down a passageway, and voltage is the force that stuff is being pushed with. A taser is a tiny bit of stuff being shoved with a lot of force. It's a high-powered pea shooter. It's enough to hurt, but no matter how hard the pea hits you, it's not going to be enough to kill you. A 12V lead-acid battery is a very slow-moving car rolling along the floor in neutral. There's a lot of stuff, but little force behind it. If you pushed back, you could stop the car. It doesn't have the force to keep going, but if you lie down in its path, it'll kill you. One of the most important equations in electrical engineering is V equals IR, where V is voltage, I is current aka amperage, and R is resistance. If you have a 12V power source, and you connect it to a high resistance circuit, you'll get low current. If you connect it to a low resistance circuit, you'll get high current. Car batteries have huge terminals and connect to beefy wires, so they have high current. Tasers have tiny little high resistance wires, so they have low current. A taser is very high voltage. But what people don't tend to mention is that the voltage drops basically to zero the instant you zap something with it. So the total amount of energy you actually apply to the target is not that much. If you keep zapping it cycles. Charge up to high voltage, zap. Charge up to high voltage, zap. Its source of electricity isn't strong enough to maintain a super high voltage while dumping current into something. If it was, it would melt whatever, or whoever you were using it on. Power, I.E energy per second, is the actual measure of how strong a source of electricity is, and it's equal to voltage times current. So a low voltage battery, like a car battery, is actually able to supply more current than a high voltage battery in general. Lead-acid batteries can produce a large amount of current because there's a very large contact surface between the electrodes and the electrolyte. Furthermore, in its fully charged state, lead and lead oxide electrodes, and sulfuric acid electrolyte, the entire path is extremely conductive. In its discharged state, lead sulfide electrodes, and water, conductivity is so low that the battery may not be rechargeable. Other forms of batteries have smaller surface areas, which limit the number of electrochemical reactions that can occur, and use electrolytes, which are less mobile in nature.
Don't forget to like and subscribe so you don't miss our next exciting video.